thanks. So I know that I see that most of you are people, researchers familiar with fault displacement hazard, but some of you maybe not, maybe the youngest researchers not. Therefore, we have prepared some slides, very basic, to break the ice and to start identifying some possible hot topics for the lab. Okay, fault displacement hazard is a very localized hazard due to the rupture of the ground surface from slip along an earthquake fault. And this may, of course, damage buildings and facilities sited on or very close to the trace of the fault. A fault which has a significant potential for displacement at or very close to the ground surface is also defined as a capable fault, according to the International Atomic Energy Agency definition. Okay, fault displacement hazard, we know it is particularly relevant for critical facilities. For example, nuclear facilities, dams. This is a very famous example of the Xikang Dam, displaced about 9 meters by the surface faulting along the trace of the Chalungpu thrust during the Chi earthquake. It is very critical also for long infrastructures, for example, lifelines, transportation systems, also because often these infrastructures cannot avoid crossing a capable fault. We also know that surface rupture can occur in the form of principal faulting. In this field, in the field of fault displacement hazard, we call a principal fault rupture, the rupture of the ground surface along the trace of the fault, which is at depth the source of the seismic moment of the earthquake. And in general, the surface, it produces longer ruptures with highest displacement. But we know also that we can have several secondary or distributed ruptures around the principal fault and distant from the principal fault in the form of some rather unpredictable ruptures, or in the form of reactivation of secondary splaying fault, or even as discontinuous reactivations of very distant faults. In general, they are also active faults, capable faults, but very distant from the source of the earthquake. And we know that we can have this principal faulting and distributed faulting for different faulting styles in strike slip, reverse, normal environments, with differences which are due to the different tectonic style, but we can have always principal and distributed faulting. And we think that, for example, a way to predict or estimate distributed faulting, distributed rupture, can be an odd topic, for example, because distributed rupturing is very difficult to predict, especially if it occurs on faults, on structures without a geologic expression before the earthquake, because distributed rupture can occur very far from the principal fault. For example, this is a diagram from a number of normal faulting surface rupturing historical earthquakes. We can have a rupture up to distance of about 20 kilometers in the hanging wall of the normal faults. And because often it is always difficult to predict, and another possible hot topic is the control on distributed rupturing of structural complexity. We see that we can have more distributed rupturing in correspondence of structural complexities, such as a step over, for example. From a geologic point of view, a classical approach for preventing the risk from surface faulting is the classical approach of zoning and avoidance, which is probably the most efficient. But we have to know the fault before the construction of the building. It is not always possible to know the fault before. Sometimes the fault is discovered after the construction. And in these cases, is necessary to perform a detailed fault displacement hazard analysis, including some probabilistic approaches aimed at quantifying the likelihood of displacement at a site of interest for risk-based mitigation actions. For the classical approach, the zoning, we have in the world a few laws or guidelines. I know those four. I think there are some questions that can be of potential interest for this lab. For example, I think it could be nice to know from the community, from end users, for example, if they work. Is there any suggestion from end users? And another point is that how one can consider distributed faulting using this approach. I think these are questions that can be of interest, at least to discuss within the lab. Then now I leave the floor to Stefan Bez. Please, Stefan, do you prefer to share your screen?
No.
Okay, so please.
No, that's okay. You can keep your slideshow. So I am Stefan Bez from France, from the Institute for Nuclear Safety. I'm an earthquake geologist. I'm here in the room with my colleagues, Sébastien Hoc, is a modeler, I can say, seismologist modeler, and with Una Scotti, who is a seismotectonic specialty and one of the leaders of the Fault2SHA group. Myself, I'm interested in, with Una and Sébastien, we are interested in surface rupture, full displacement hazard, sorry, since a small 10 years. And that's it. We are working on gathering the database for building the empirical regressions, and Sébastien especially is working on dynamic modeling of the rupture at the surface. Okay, so that was the introduction. Let's continue on full displacement hazard. So in general, as explained by Paolo, the full displacement hazard analysis is conducted through a probabilistic approach. And basically, this is an extension of the classical ground shaking probabilistic analysis, FDH. And this has been formulated by Young et al. In 2003. And the final result of PFDHA is the estimation of the likelihood of occurrence and expected amount of surface displacement during an earthquakes at a site. And this is usually used, as explained before by Paolo, when we cannot avoid the fault, for example, for lifelines, for large facilities like nuclear power plants, for example, or in some applications where the fault is discovered after the building construction, especially in the nuclear industry, when the site is existing since the 70s and the fault is discovered by someone, the geologist, we engage fault probabilistic fault displacement hazard analysis. And for this, what is needed is first we need to know the rates of earthquakes we can expect on the fault. So this is usually estimated through the earthquake catalog in the region, but also from the data that we can get from the geology of the fault. So basically the slip rate. And for going further in prediction of this occurrence and amount of displacement, we generally use empirical regressions. And these are two examples for, can you show with your, exactly. Good job. For the distributed rupture, these are the regressions that were elaborated by Young et al. in the pioneer work on PFDHA. So the first one is giving you the probability of occurrence of distributed rupture from the fault, from the principal fault to the left, so zero distance, at distances up to several tens of kilometers. And the right one, on the right panel, you see the prediction of displacement that can be expected and predicted from this data set. So next, please. Next slide. Yeah, so basically, this empirical regressions is based on historical earthquake mapping and measurements of displacement in the field. So this is an example you have on the left panel from an earthquake in the US, in the Western USA. So this is the Dixie Valley earthquake, quite large for European context, 6.6. All you can see on this map are the surface rupture segments, either the primary rupture in red or the secondary or different categories of distributed ruptures in blue and in yellow. And you have the corresponding measurement of offset as circles. So to build these regressions, we need this kind of data set, which is quite time consuming to get in the field. One of the hot topic we can identify as soon as now is that the empirical data sets are quite poor, especially the one that was at the base of the Young et al. Regressions. I give you here the example we know the best, my team. This is the SURE 2.0 database, which has been published very recently and gathering 45 earthquake datasets. So we will present here only 16 reverse and 18 normal earthquakes that could give sufficient data to derive regression relationships. And the pies that you can see on the two panels to the bottom are giving you the amount of data that are in the data set. So for the normal force, for example, we have more than 700 kilometers of rupture cumulative rupture length. And we have a lot of measurement of data we have a lot of points of measurement of slip, more than 10,000. And this is shared between 50% on the primary fault and 50% on the distributed fault, the ruptures. So this is one of the first hot topic we have, is if we compare to the PSHA world, is that we have very few data compared to them. And this could be one of the big topic we could address in the lab, is trying to get more and more data. Next, please. So the surface rupture at during the earthquakes, whatever in occurrence or displacement, are basically controlled by first the magnitude. So the more the magnitude is, and the more you can expect to get a long rupture with a high displacement. This is also depending on the geometry of the fault. Of course, if you get, for example, for a fault that is dipping is very shallow, dipping 20 degrees at 10 kilometers at depth, there is a very low probability to get the rupture at the surface. This is the same for the depth of the rupture, the nucleation depth. We know that we can get surface rupture for very shallow earthquakes of low magnitude. For example, in France, 3 years ago, we had a rupture of 5 kilometers long for magnitude 5, so at 1.5 kilometer depth. So this is other controlling parameters. And one parameter we are not we are aware about, but we don't use it now for predicting the rupture at the surface, is the near surface geology, for example. This is one of the topic we could address as well in the lab. This is very difficult now with our data and with our concepts to predict this and to quantify and to account this in hazard calculation. Next one, please. So this is sorry. There is another parameter. Sorry, can you go back? I forgot the one.
Yeah, there is some delay. Sorry, but
yeah. Another one is the thermomechanical background of the area, and the map you can see here. The map you can see here on the slide is from the Mammoth Lake earthquake in the US, where we suspect that the principal fault is split into many small ruptures, short and small displacement ruptures, when emerging into the volcanic caldera of the Long Valley. So this is another parameter that is important for, and this has been observed as well in the during the Kumamoto earthquake in Japan. This is something we could try to anticipate in the topic of the lab. Now you can move to the next, Paulo, sorry. So this is an illustration of the near surface geology influence, and this is from a case again in the North America during the 2010 earthquake in northern Mexico. Those two guys, Terran et al. And Fletcher et al., they could really in a very high detail, and others of course. These are my two examples here, but there were many studies on this earthquake, and this because of the good, let's say, good conditions of outcropping, they could map really in detail the surface rupture, and it was clear that there was an influence of the rheology of the surface material, because if you see on the middle panel. Yeah, you can show the middle panel, Paolo. What you can see on this panel is that the number of scarps significantly increases with the softness, let's say, of the surface geology, as well as the thickness of the rupture zone. Not the thickness, but the wideness. I don't know how to, the width, sorry. And that's it. This is to the right panel. You have another example of what was evoked by Paolo first, is the map. You see an aerial photo of the rupture of the El Mayor-Cucapa earthquake. This is the dashed line is the principal rupture, which cut the road. And you see, and this is in an area of geometrical complexity of the main rupture. There are several, if not a lot, distributed ruptures in this area. They are underlined by the yellow arrows. So, okay, you can. So this is one of the topic we already evoked before: the impact of the surface geology and fault complexity in the distribution of deformation at the surface. So you can move to the next one. Paolo, thanks. So as a summary of the comments we gave before, Paolo and Francesca and myself, we have to remind that the core of the Fault2SHA group motivation is the interdisciplinarity, and I guess the fault displacement hazard topic is a good example for this, because obviously we need field geologists to fill the databases, but we realize in the recent research effort that there will be a significant contribution for the physics-based modelers, which can provide constraint on the surface rupture phenomena. And this would be useful to get those guys with us. We realize as well that we need a lot of the geodesists to get all the signal of deformation during the earthquakes, and this has been very well imaged during the recent big earthquakes, thanks to, for example, optical correlation works. So we already identified several hot topics. So this is our own evaluation of this, but this meeting and this kickoff meeting is especially dedicated to share your expectations. All the group, the 25 people here, maybe you can highlight others or topics we didn't identify yet. And the last point from myself is that we have to get in synergy. I don't know if it's the right word in English, but with the fault displacement hazard initiative that was lasting for 4 years in the US, with the monthly meeting, sharing the same database, so FDH database, and working in different groups to derive a prediction of sleep during earthquakes. So we have some people of the FDH group in the room. I see, for example, on the screen, Rob, but there are many others. Not many, but there are others. Next. Okay, so that's all for me. Paolo, maybe we can move to the.
Yes.
I was a bit long, sorry, but now you can talk. Yeah.
Now the moderator is Francesca. So now that it's time for
Francesca,
you, for you participants to introduce yourself and to propose ideas if you have. Francesca, you decide the order.
Oh, what a responsibility. So I think we can go by blocks, the same institution, I mean. And I also know that someone has one slide to share with their work. So I can start in a shameless self-promotion of University of Insubria. So I'm Francesca Ferrario, I'm a researcher. I'm doing Fault Displacement Hazard analysis since not a long time. And so far we focused mainly on empirical data and on exploiting data sets and this kind of information in the Apennines mainly, but also with a global perspective. So within Insubria there is Professor Franz Livio, who I think has one slide and you are able to share in Teams. And then we have PhD students, Marco Pizza, Giorgio Tringali, and Michela Colombo, who, if you want to present yourself, the floor is yours. So Franz, go first with your slide.
Yeah. Thank you, Francesca. Hello, everybody. It's so nice to see so many authors of the papers I read in the same room. So thank you for being here. And I'm really glad to be part of this group. Yeah, so it's true. I've got a slide, so I will share my screen. Okay, here I am. So hello, I'm Franz Livio, and I am a scientist. This is my email address. So I'm a field geologist. I was born as a field geologist. I mostly worked on fault and thrust belts. And then I spent some time, quite a lot of time, on the Central Apennines also. So my main topic of research about that can be of interest for this group is about distributed faults. I spent some of my time researching on this. For example, this is an image after Serva and co-authors 2019 earthquake spectra that is showing the INSAR deformation during the following the October 2016 earthquake and some very rough traces of the principal in red and distributed ground ruptures in black. And it is really striking how they are perfectly matching the extent of both the geodetic deformation, the crustal deformation, and the localized ground ruptures. So if I can introduce one thing to think about is investigating the relationship between stress transfer and strain and the occurrence of distributed ground ruptures. I would like to think about a geological sounding model, something that is really strongly based on the linkage of structures at depth, the structural relationship, as Paolo Boncia said, that can help in predicting the occurrence of distributed faults based on something a little bit, more geologically sounding than just distance from the principal fault. This is quite a dream, I don't know. Okay, so this is my contribution. Thanks.
Thank you, Franz. Is there someone else from Insubria who works mainly on the same stuff who wants to show up? I'm the shy in the group. I must say that. Okay. So anyway, if no one is... Okay, Giorgio, go.
No, I haven't a slide, but...
No worries.
I would like to introduce myself too. I'm Giorgio Tringali. I'm geologist, a PhD student at the University of Insubria. I'm at the final step of my PhD. And I've worked mostly on the surface faulting, on volcanotectonic environment on Mount Etna. So I would like to work more on the factors affecting the surface faulting, for example, on volcanoes. But I've worked also with paleoseismology, mostly in Central Italy, with Franz, Francesca, but also on Mount Etna. We are planning also new paleoseismological trenches. And okay, quick.
Good. Thank you, Giorgio.
Welcome.
Okay, if someone, okay, so I think Paolo group, your PhD students has some slide or postdoc also slides to share, or so let's move to Unichieti. Sorry for the Italian accent and taking too much space.
So I don't know if Lisa is connected.
Yes, I'm
Lisa,
here. Everybody's waiting for me, sorry. Okay.
No problem.
Okay. Hi, everybody. I have one slide. I'm trying to share the screen. Okay. Okay. Can you see? I think it's shared now.
Yes.
Okay. Hello, everyone. I'm Lisa. I'm a first-year student at the University of Chieti. My PhD project deals with the probabilistic for displacement hazard on principal fault. And PFDHA is very important for the safetyness of sensitive infrastructure as nuclear power plant pipeline. And I'm going through the earthquake approach for PFDHA according to Young's et al. And specifically here I reported the fault displacement attenuation function. Since now I'm working at the conditional probability of surface rupture on principal fault. And few studies are available in literature on this topic, and each one there is the probability of from empirical model and based on logistic regression applied to the datasets. And in this image, I'm showing those results, and some issues come out especially for reverse fault, which is the red curves. And these issues are why reverse fault didn't produce surface rupture, and is that related to the blind fault or for faults located in remote areas, or how can we understand this divergence? And moreover, those databases contains events from different tectonic environments and different seismogenic thickness. And so for this reason, we are looking at an analytical approach to fill out this gap. And the numerical model, the idea is to put together all these questions we need to answer. So figure out some way to define the width of the fault source and the width of the rupture, and then define the rupture propagation model using a simulation approach where we have a distribution of what the hypocentral depth are going to be. And after that, using this rupture propagation model, we can run the simulation and have all the results be yes or no in order to compute the conditional probability of surface rupture. Since now those are my ideas, and I don't know what I can say further.
Thank you.
Lisa.
That's
really
okay.
Cool. Okay, so there is someone else from Unichieti in the same group?
I think Alessio, maybe.
Yes. Hi, everyone. I didn't prepare any slides, sorry, but I just want to briefly share my experience with PFDHA methods to highlight their weaknesses. I'm going to defend my PhD thesis in a few weeks, and my project deals with the fault displacement hazard analysis of strategic infrastructure, precisely for the safety of a strategic dam in the Northern Apennines. I've worked on the data gathering on the field and on the application of existing methods of PFDHA. Particularly, I used the fault parameters to apply the methods proposed by Youngs in 2003, Youngs and co-authors. And I try to improve it, integrating the newly and updated regression from Ferrario and Livio for 2021 for the probability of occurrence of primary faulting. And I think that my experience allowed to highlight some weaknesses of these methodologies, especially regarding the secondary faulting. For example, even if it is quite old, the methods by Young is the only one available for extensional settings, but both the relationships for the probability of occurrence of distributed faulting and the displacement distribution with the distance from the main fault are poorly constrained, being based on database with very few data, very few earthquakes, and very limited geographic distribution. As I said, Ferrario and Livio already improved the relation for the probability of occurrence of distributed faulting, but for sure, more work is needed for the displacement distribution with the distance from the main fault. Moreover, the probability of occurrence of distributed faulting usually is a function of the maximum or average displacement, disregarding of the displacement variation along the strike of the principal fault. And this is another issue, I think. Another limit, as Stefan already said, is not taking into account the near surface geology, which can of course affect the probability of occurrence of distributed faulting, and also the presence of secondary structures and pre-existing discontinuities is not fully addressed in these methods. Even if it can affect the probability of occurrence of distributed faulting too. That's all. If you are interested in, I would like to share my findings in detail in the future with pleasure. And that's all. This is my experience. Thank you.
Thank you, Alessio. I think we have a bunch of people from Arizona State University. I'm not sure who wants to share. I know you have one slide. I'm not sure who is going to. Rachel, maybe?
I think Rachel, she will make the presentation. Hi, everyone.
Hi, Ramon.
Yeah, hi, I have one slide. I'll share my screen. Okay, can everyone see that?
Yeah.
Great. We are our research group from Arizona. We work with Dr. Chelsea Scott, Dr. Ramon Aerosmith, myself, and Mindy are both grad students, but we are working pretty closely with Pacific Gas and Electric, and there's a couple of you guys on the call as well. But the goal of our research right now is to quantify and reduce the fault location uncertainty to reduce the overall hazard associated with future rupture. And kind of like our hot topic, I suppose, is the idea of doing a pre-rupture fault map. So we are using data that was acquired before certain large earthquakes of study and mapping the faults remotely using geomorphic indication to see how well we can predict future rupture, and doing some subsequent analyses on those. And Chelsea is coming out with a paper that just got accepted into Geosphere that goes a little bit more into this, but that's pretty much that's the 30-second elevator talk, unless Ramon, you'd like to add anything.
No, that was great. And then, so Chelsea's first paper is in press. We're looking to your paper, Rachel, to be submitted in a month or two, and then also Mindy will have another one. And so really excited about this topic. Also, we have a collaboration with Alba Rodriguez Padilla, who's here on the loss of information after earthquake surface ruptures due to surface processes. So another hot topic. So anyway, I think we did want to volunteer when the list of possible presentations, full-length seminars is made to go into greater detail on our work.
Thank you so much. and we will for sure take your offer to invite some of you to give some talk. I will share another, again, my screen, because we had one slide from New Zealand where it is, I think, 3 a.m. now. Okay, it's even, okay, I didn't try that. Okay, that's even with animations. So Tim Stahl, who, sorry, I don't know personally their group. So, well, he wants to he get in touch with us and wants to share these slides. So apparently, maybe you know much better than me, but their group is working on you know, connecting fault rupture and, let's say, secondary effects. So fault rupture induced floods. I think this paper just came out a few days ago. And also fault deformation and seismic landslide susceptibility. I need to read this paper. So and then I just read this what they are saying. So geologists and engineers there in New Zealand and elsewhere are very interested in developing PFDHA for New Zealand from all angles: regional empirical models, physics-based models, better site characterization, and so on. Oh, so thank you. They are excited to have nationwide LiDAR coverage in the coming years and look forward to interact with and learning from our international colleagues. So I'm very, very happy to have, again, a wide distribution in terms of geographical settings, but also topics. So let's get back to.
Will be challenging to define a time,
yes,
which is convenient for all of us. But okay,
that's the drawback. But it's better to have everyone on board. So yeah, now I don't know who wants to add and to introduce themselves.
We have a candidate at IRSN.
Okay.
Perfect.
And just add a word at IRSN, because we didn't talk about that yet. I am actually a source physics model, and in the recent years we've been implementing some rupture dynamics models with a special focus on the surface rupture, and of course the idea is to help to give some interpretations about surface ruptures with the near surface geology inputs, data, and also structural geology, together with the physics of the rupture, and to see if we can gain some information on surface rupture. Could be the variability of the principal fault surface rupture amount of slip. Could be also the likelihood to trigger some distributed rupture on all fault structures, or could be also investigating the width of the surface rupture zone. Any kind of these topics that we could model with some physics inside. And yeah, that's also a hot topic, because it's not easy to do, and we need data, and we need to collaborate with field geologists to understand what we are doing. And also we need to have some good physical models with that, so we need to calibrate them.
Okay, thanks a lot. Now the floor is open, so anyone who wants to add or present your work, you are welcome.
Francesca, I can. Well, can you hear me?
Yeah, now yes.
Yeah, okay, sounds good. Hello everyone, I'm Francesco Iezzi. I'm a researcher in the University of Naples. If you want, my experience with fault displacement hazard is quite recent and started working on it a few years ago. And I'm mostly working on the deterministic approach. So basically, I'm looking at fault traces and try to identify fault traces as best as we can, and then moving towards the zoning approach. So I'm definitely interested in working more on this and also in improving myself towards the hazard probabilistic approach side, because it's something that we need to do. Also thinking about the hot topics that you all showed, I think as a structural geologist myself, I think that one of the hot topics that we should pursue is the role of the complexity in fault traces that we observe and how they affects the distribution of seismic ruptures along the fault. Because I've been working on this throughout my time, my career, my PhD. We observed some effects that the structure of a fault causes on the distribution of core seismic throws. So I think that this kind of things needs to be addressed then in probabilistic hazards and so on. So yeah, that's my take. Thank you very much. Thank you very much for organizing this.
Thank you.
Hello everyone, this is Ishan Shrivastava. So let me share. Hi Franz. Okay, if I can share my screen, yes. So I'm a PhD student in IIT Kanpur, but now I am an Inqua Fellow in University of Palermo, and in coming few months I'll be defending my thesis. So I'm working, I got my degree in geophysics and seismic attribute as a master's student. Now then I switched to active tectonics paleoseismology, and with Professor Javed and Malik in IIT Kanpur, India, I am doing paleoseismology and active fault mapping in Kutch. If you know Kutch, it has a devastating earthquake in 2001, and there was one more earthquake of similar magnitude in 1819, Allahband earthquake. So I'm working near the epicentral region of 2001 Bhuj earthquake, and I'm trying to do trenches. And if people who are dealing with the SCR region, stable cratonic region, which is this region, they know that how it is hard to do trenches, to have a successful trench in this area. I have done multiple trenches, and 2 to 3 trenches I got success, and one trench I'm able to kind of submit in tectonophysics. And in coming few months I'll be submitting one more trench, which is more towards the epicentral region, which is over here, and for the publication. And now in University of Palermo, with the close collaboration with Francesco Brato, I'm working on the morphotectonics. I'm learning morphotectonics and looking on the long-term deformation in the Kutch region. And in future, after completing my PhD, I have an offer in place with Professor Sulli, who is also my co-supervisor, and I will trying to do some offshore paleoseismology, because in AmTech I did seismic attribute analysis, and with that I have developed to kind of differentiate discontinuities from seismic datasets, 2D, 2.5D, and 3D dataset. In masters, I worked on a dataset from Canada Offshore Petroleum Board, which is near the dataset was from Nova Scotia. I kind of generated a fault cube, and I'm trying to do similar kind of work in near Sicily. We'll try to differentiate fault, and if possible, do some offshore geomorphology. And if I get hands on some CHIRP data, high resolution seismic data, I will try to do some offshore paleoseismology. I don't know if I'll be successful or not, but we'll try in coming few months. Thank you.
Thanks a lot.
I have a suggestion, Francesca.
Yeah.
Well, PFDHA is dedicated to application to sites, and we have end users in the room. So it would be nice to get some words from them. How do they practice? Do they have special expectations? I don't know, new models, new maps, new blah blah blah, new data. If they have data we don't have, I don't know. Where are the end users?
I fear that there are no end users in this meeting, Stefan.
Well, I guess I'm now
Fia, please.
more of the end users side. So yes, my name is Fia Nurminen. I did my PhD in a group of Paul and Stefan, Una, and all. And but like nowadays, more than a year, I've been working in RINA Consulting as a seismic hazard specialist, and have switched to the other side of the BFDHA. So as a group, we apply BSH sites, both onshore and offshore. So that is at least one thing could be a topic of interest, and a special kind of a application we've been kind of forced to develop here, in like having those kind of projects on the table. But yeah, thank you for organizing this, and I'm happy to be here still, even if changed from academic world to the private sector, and I hope I can participate also in the future, the conversation.
Thank you.
May I ask a question to Fia? Offshore cases, are they tectonic faults or, I don't know, gravitational?
Yes, also tectonic faults.
Also, so you use PFDHA for non-tectonic faults?
No, obviously we use it, like, it depends of the data how strongly we can state something, but like of the type of the fault in offshore locations. But like obviously the idea of BFDHA is to use it for tectonic faults.
My question may appear stupid, but in the past I read a paper in the Gulf of Mexico applying PFDHA on let's say gravitational faults on top of on the passive margin, and this is why I asked the question.
Yeah, I think I know what you're referring to. Well, there's the salt tectonics.
Yeah.
The case? Yes. Okay. Yeah, that was that has been done. Now we have like different project sites, but like, yeah.
I see that there is another end user, Yassine. Do you want to show up and present yourself?
Yeah, okay. Can you hear me fine?
Yes.
So hello, I'm Yassine. So I was trained as a geologist, earthquake geologist. So I worked in studying morphotectonics, paleoseismology, mainly in Turkey, along the North Anatolian Fault, and also a bit in Mongolia. So mainly on big strike slip faults. And then some years after my PhD and a postdoc, I switched also to the other side of the force, and right now I'm working in a small seismic hazard company in France, which is called Seister. So we are mainly dealing with PSHA, classical approaches, but more and more for a few years PFDHA. And so what I can maybe suggest is that so as practitioners, we are dealing with a lot of empirical models to predict probabilities of rupture, probabilities of exceeding a certain displacement. And most of the times, all of these models were developed by different teams, relying on different kind of data sets, using different methods. So a priori, there is no, the consistency, when we do the calculation, we have to combine a given PSR, probability of surface rupture model, with a given empirical model for scaling the fault area, the magnitude, the displacement, and then with a given model to predict the amount of primary or secondary displacement. And so for us, it is an issue to be sure that all of these laws that we use are consistent between, that we don't explore combinations of parameters and regressions that lead to not credible sets of parameters. And for example, when we are dealing with average displacement or maximum displacement, because a lot of the models that predict the displacement at the surface, they are normalized to the average or maximum displacement of the main shock, for example. And so actually, the empirical models to predict the average or maximum displacements are very few. Maybe we have Wells Coppersmith, we have Leonard, more recently we have Moss and collaborators, but there are very few. And we struggle to ensure the consistency between what is predicted for the average displacement, what is predicted for the maximum displacement. Do we need consistency between both of these parameters? Do we need to adjust the average displacement at the surface with what happens at depth on the fault plane? And when we are dealing with maximum displacement, how do we account for example, the near surface lithological conditions? I think this is a very interesting topic. So introducing physics-based considerations and also accounting for the diversity of surface rocks and stuff like that to, I don't know, refine or improve or be more credible when we use the empirical models is a real issue for us. And I will finish here. I talk too much.
No, also thank you for your input, because that's what we need, because otherwise we are not posing the right question. And that's why we are very happy to have also practitioners within the group. So is there anyone else who wants to add?
I have a question to the attendance. Is there some, sorry, Dylan. No.
Yes, there is the.
Go on.
I raised at the end.
Okay, well, I might as well introduce myself. This is actually my first Fault2SHA meeting other than talks, so I'm really, really pleased to be here, and I've been looking forward to this meeting for quite a while. So let me see if I can figure out where I'm supposed to be here. So I'm a lecturer at Imperial College London. I'm a geologist, geomorphologist, and geochronologist, specializing in cosmogenic isotope surface exposure dating methods. I've been very lucky over the last, I don't know, 5 or almost 10 years, I guess now, to be working a lot with PG&E up in this part of the world, up in northeastern California. It's where I kind of first got introduced to PSHA and then eventually PFDHA. And effectively what I've been doing with PG&E over there for quite a while now is kind of developing unconventional paleoseismology methods, which I'm happy to talk about give a talk about if you'd like. But myself and my students have basically worked over the years with PG&E to kind of define fault locations and geometries around these. This map is basically showing all the pipeline crossings, gas pipeline crossings in the PG&E network, crossing active faults. This is the crossing of the pipeline across one of these active faults in the Hat Creek Graben. This fault zone also kind of intersects this important concrete dam. And so basically, we've been working with PG&E to define the fault location and geometry of these faults, the slip rates of these faults using surveying and LiDAR and dating methods, constructing displacement profiles across all the active faults, developing recurrence intervals by, again, dating mostly seismically triggered rock falls, but also dating bedrock fault scarps. So we get recurrence intervals in most MREs. And so most recently, just last year, I started talking with the crew at GEM, Marco and Richard and Anna, about basically using these types of data. I realized I have all the inputs that we need for PFDHA models and actually integrating them into the OpenQuake engine with GEM. And it was Marco, I credit him with directing me towards this group. And it was actually because of that interaction that we started to do this. We started to work on a proposal for the Horizons 2020 call that looked at pipeline displacement hazards for active faults across Europe. And so I guess this is a bit grandiose, but I would say that this is something that's definitely a hot topic. Gas delivery across Europe is a big deal. And this is basically showing the network of pipelines crossing all of Europe. And it's plotting all the dots or the intersections, and they're color kind of sized and color coded with bigger and darker colors indicating higher slip rates on the faults. And so I was amazed for the first time when I plotted this up with my wife, because we had no idea that there were so many fault crossings across Europe. And so I think this really makes the message clear that fault displacement hazard, especially in Europe, is a very big deal. And there are a lot of pipeline crossings in terms of hazard and risk that we need to be thinking about. So that's all for me. Thanks.
Thank you.
Thank you.
Anyone else present something?
Laura, do you want to talk about our past attempts to find money for this kind of problems, like the cost initiative?
I was waiting you for.
Oh, I'll leave you.
Not too long, huh?
No, not too long at all. Well, nice to meet you all. I'm Laura Peruzza at OGS, the northern corner of Italy. I'm particularly glad that we started with this initiative because, well, I have to say that I belong to the generation of Italian geologists that were taught at the university. We learned that earthquakes in Italy do not give fault rupture. So you realize how old I am, but no matter. Now the interest in fault rupture is increasing, and the reason why it is increasing, I think that Dylan showed it a few minutes ago. We are crossed by pipelines, and we have several other energetic industry network that have to be realized or have to be retrofitted. And I'm glad that the initiative involves people from other countries, even if, of course, the core of the Europe is let's say our starting point. We were born below the umbrella of the European seismological community. We have, as the Fault2SHA working group, I mean, we have no money from the European Seismological Commission. We have decided that we don't want to have a lot of money, but just the money that we need to handle workshop or meeting of people that can share their experience. There will be the next General Assembly will be in Corfu in Greece in 2024, and this should be, for example, a deadline for the lab for having a dedicated session or a specific training course during the General Assembly. Una previously mentioned that we applied for several times to some cost action, not specifically dedicated to Fault.
Questo è ciò che ho trovato sul web per specificare. Dai
No. There is my series stuff that is starting against my desire, let's say. I was saying that the cost action that we applied during the last year went with no result, and up to now we have no, let's say, energy to try to apply for another topic. But of course, if we are able to gather around the table modelers, data providers, and users for such a specific, such an important topic of like the fault displacement hazard, well, we think we can try again to receive some funds here and there. In Italy nowadays, it is a very particular moment because we are under the wave of an extraordinary fundings of research as well, given by the National Resilience, and I don't know the acronym in English. There was an extraordinary funding coming from Europe that involves most of the university and most of the research institution. Not necessarily money means ideas and method and growing of the community. And so I'm particularly glad that we are trying to involve a larger community for these reasons. That's all on my side. Una, what I missed?
Thank you, Laura, for this background. I mean, I think that one of the aims of this group should be to try to aim for re-updating the cost proposal, but not right away. I just wanted to say that there is a base and that we can think about trying to do it again. There are a lot of interesting ideas that came up today, and I think through the learning series that Francesca will organize, we will probably soon enough get some very interesting ideas going. So that's it.
Instead of applying to the European Community, we can apply to the Italian government, if I understand well.
It doesn't work like that.
No, sure.
No. I'm sorry.
Okay. Bruno.
Yes, hi everyone. Just a few words. I'm Bruno Pace from University of Chieti. Sorry, another Italian. And I want to, first of all, as a member of the Fault2SHA XCOM, I want to say thank to Francesca, Paolo, and Stefan, because it's really important to have such kind of working group. This laboratory, we call it laboratory inside our working group, because the philosophy of this group is exactly the philosophy of the Fault2SHA working group, to have different people with different background from different countries, from geologists to modelers to practitioners, and to have to talk together on the same topic with different background. I think we can really do a step over. And what I just a general suggestion, thinking how we started also working on ground shaking, seismic hazard modeling. It's important to start also discussing a bit, I know maybe it could be boring, but about the definition of the the things we have to discuss about. For example, the matrix is a problem. How we can have a common definition of a database is an important point. The ranking of the faults, if we discuss about distributed fault, is something that we have to decide and give the right name to everything. The same name. It's not the right one, but we have to understand each other. That could be easy, but sometimes it's not. We can do a mistake only because we are using different names for the same thing, and could be a good starting point. This. And also, as I say, the database, we have now a lot of people working also in the SHA database. The USA people work in different databases. I think to discuss how to have the right database, how we can organize the data in the best way, useful also. I agree that is the aim to have a code like OpenQuake Open also to calculate something about for displacement hazards is really important, but in particular in this case we have to define in the right way the matrix and the definition of everything we are putting as input in this kind of codes. And that's all for this point. Just the last point, we didn't discuss, but I have seen in the last slide that you are thinking about some topic talks on this. I think it's a great idea. And I remember you also that we have also YouTube channel of Fault2SHA working group that can be used also we can record and stream there the talks, and could be useful because in part we had the learning series on different topics. Maybe sometimes it's not followed by a lot of people during the exact time of the talk, but then the YouTube channel can help, and in particular if we grow the group, we can share, we can use for in a different period. Obviously, we have to agree about the recording of all the talks, but I think we can discuss about that. That's all. Thanks again to organize this.
Thanks, Bruno.
Thank you, Bruno. Paolo, maybe you want to close with the future plans. So what just Bruno launched.
Yeah, I see there is also Alessandro Valentini. I don't know if you can spend a few words about your experience from from is private is now here. Maybe Alessandro is not.
Yes,
your experience
here.
in IAA.
Yeah, can you hear me?
Yes.
Yeah, I'm sorry, I'm not at home. I'm just working with just a second.
If you can't, Alessandro, sorry about that.
Yeah, no, I can. I'm just working with my son because at this time it's quite nervous, so I have to work and I cannot stay at home. And by the way, yes, I am Alessandro Valentini, everyone. And I started to work on FDH more or less around 2019, and with a group of Paolo at the University of Chieti, with Bruno, Francesco, Fia, Alessio, and from September 2020 and August 2022, I worked for IAEA, for the International Atomic Energy Agency, and I was a project manager for a benchmarking exercise. And it was a quite huge exercise. We involved a lot of people from everywhere. And I also knew a lot of people. And it was a very good experience because for the first time we had the opportunity to to check the published PFDHA code, to make a comparison, to discuss the comparison, and also to draw a lesson learned from this exercise. Everything will be published, I think, soon, maybe at the end of the year. Everything will be published in a technical document by the agency. And I think also we will publish a summary on earthquake spectra special issue. And so everything will be published soon. And yeah, there is. I'm quite very happy about this project again, because I think it's a good starting point for PFDHA. And because PFDHA started in 2003 with the work of Young's. And then around after 10 years, Peterson, Moss, and other works. But now I think the community is growing very fast. So we need to collect all data and all models, all regression. And also, I also think one important thing is to have, maybe someone already mentioned this, but I think now it's very important to have an open source platform like OpenQuake, where everyone can use this model. Everyone can run Peterson model, Young's model, and the other models. So this I don't know how to do this. I don't know how money we need for this. I don't know who can do this, but I think this will be a very, very important starting point for PFDHA. And yeah, that's all.
Many thanks, Alessandro, and sorry for having intruded your life.
No, it's okay. This is my little earthquake. Today is magnitude 7. So sometimes it's magnitude 3, magnitude 4, but today is magnitude 7. So I couldn't stay at home. So, but it's okay. It's fine. I follow all discussion, and thank you very much for organizing this.
I think the experience by Alessandro can be of benefit of the group also. No, maybe a talk can be on the benchmarking. Can be really useful to continue the discussion on this, and to find ideas for a common.
Yes, as soon the paper will be published, at least on earthquake spectra, I can give you a talk, because now there is a sort of confidential agreement. So maybe it's not the. I know that most of you work in that project, but there is this sort of confidential agreement. But I think the paper will be published soon on earthquake spectra, and then after that I can give a talk to show you what we did in the last 3 years.
This is important. This information is important to organize. Thank you, Alessandro.
You're welcome.
Okay, the aim was to be not too long, just start, introduce ourselves and start discussing, so we can go to some conclusions for today, at least. So planning for some future actions. We already have some ideas. The easiest probably to start having some talk series. No, it should be easy in theory. First, okay, any technical problem if we continue using Teams? Sorry about that, but sometimes there are some technical problems. I think no, today everything was smooth. Okay, the idea is to do some talks, not necessarily regular in time. Let's see, can be on a bi-monthly basis. but flexible. The idea is to have, let's say, can be one talk or two talks in a meeting with sufficient time for discussion. For example, one or two talks, maybe 30 minutes long, and half an hour of discussion where we can, you know, start discuss on possible hot topics where we can converge, or where we can around which we can create subgroups, sub-working groups. For example, Stefan suggested to identify, for example, 2 or 3 maybe hot topics, and then create subgroups working on the topics. One can be, for example, the effect of thermomechanical properties on distributed faulting, or near surface geology on distributed faulting, for example. But the talk series should help us to know us better and to find no, the best topic on how we can converge, on which we can converge. Laura, you have raised hand?
Yes, just a suggestion, considering also the experience we had with the learning series that is organized by Joanna. My suggestion is to split the talk into different into different types. Let's say, ask for a lesson that gives a comprehensive view of some subject, or ask for a talk describing the very last result one has in his hand. So in this way, the recording of the lesson, more general lesson, should remain in the YouTube channel. And conversely, the talk focus on specific results may be the starting point of a collective discussion. And the second suggestion I do is let's try to keep the organization as simple as possible. Because if we are splitting the group of 38 today, let's say 50% tomorrow, that now belong to the lab in subgroups, the result will be that we will start discussing inside the same community. So data providers with data providers, modelers with modelers, and end user, if we have end user, between end users. And this will not give an extra benefit that we experienced during our last workshop, our last other experiences, let's say. This is my opinion. Thank you.
Thanks a lot, Laura, for this suggestion. We will benefit from this suggestion, yeah? Okay, let's cancel the subgroups idea. Maybe find just only one.
Sorry, Paolo, another point that I forgot before. I worry for the talk series teams is not the best, because the problem is to have really a large number of participants. Maybe we haven't, but could be a risk. And in our experience, we use the Zoom. Zoom is more stable and could be directly connected with the YouTube channel. So let's think about that.
Yeah, as you know, this Teams is due to the fact that our university has, is the official platform used by the university.
I know.
It is, we can use this freely, and this is the reason, because Zoom is not. But we can, thanks, Bruno. We can discuss about that and find the best way.
I had a comment on the comment of Laura. I know this is a danger to split the community into topic subgroups. If we do subgroups. However, it's in my opinion, if we compare to the other thematic labs, they had a clear objective. For example, the Apennines was to compile a database of the active faults, and the Belix as well. Our group is a bit has no clear objective for an outcome. So I'm afraid that if we don't have any, if we do not define any hot topic to address, we will. It's very interesting. We will have discussions, but what will be the outcomes? So maybe, I don't know. Maybe at least it's not time to cancel the idea of groups. Not too many, but I think it could be interesting to get one or two at least. It was my comment to the comment.
Okay. We will think about that. If we find a convergence, we can define to, work on one or topic, or two if possible, if feasible. But in any case, the idea is to start with some talks that can be of general interest. For the time, the period, our idea was to start in early autumn. The last week of September. This was our idea. So please take notes on that. Save the week in the agenda. We don't have the day, but if we agree, we can define soon a day and define the date. So who can do the first talk? Is there any application?
Any candidate?
Any candidate?
You are welcome.
To be honest, the idea was to invite someone from the Fault Displacement Hazard initiative. That group did a lot of things of common interest. It could be very nice to have a talk from one of them. There were Rob Moss, but he left the meeting because of another meeting in parallel. So we can try to ask them if they can do the first talk can be a good idea, in my opinion, to start a discussion, knowing what they did in the recent past. What do you think? We can ask them?
Paolo, you can ask to Alex Sarmiento.
Alex, yes.
Yeah, she's very nice and she always available. I think she will give you a positive answer.
Yeah. Thanks, Alessandro. Alex in the lab. Is a member of the lab. I think she's not here because she's busy, but we can ask her. Yeah, to have can be also one talk, only one talk, quite long.
There was a candidate from the University of Arizona, no?
Yes, sure. Yes, from Rachel, no?
Yeah, we would be happy to give a talk. We work with Alex and Chris and everyone at PG&E too, so we can also give their perspective if they're not able to present too.
Okay.
Okay, cool.
Okay.
As I said in my introduction, I also would like to do it. If you are interested in, I can show you an application of FDHA, maybe the first time in Italy for our strategic infrastructure. It would be a pleasure for me. If you want. This is Alessio.
Thank you, Alessio. Yes.
So that's okay. Paul, again, maybe I can do not the first one, but maybe the third or the fourth I can do. I think at the end of the year, December or January would be fine for me.
Okay. Can be Alex. Okay, can be plus. Sorry, Rachel, like this. Is that correct? The name? Okay. Then Alessio. Okay. But I think for the first time can be Alex and Rachel.
Yeah, I was not referring to the first. It's just a proposal.
But in any case, we are happy if you propose your talk also by email to me, Francesca, Stefan. Then we can organize.
Yeah, okay.
It's time to conclude, Paolo. No?
Yeah, sure. I think we will arrange a repository, maybe for some material that we would like to share. We will inform you. First, if you agree, you can send us the PDF of your slide, and we can put into a folder. Okay. Then we organize a repository. And then, okay, the last one is, yes, it's a new information. We have asked for applied for a special session, for a session at the forthcoming International Geologic Congress, which will be held in Korea in August 2024, and they accepted our proposal. So we have a session for displacement hazard, is surface faulting and near fault earthquake hazard. The idea is also to bring talks also about near fault, very near fault hazard, also ground shaking, very near fault ground shaking. So please save the date. We have a place where we can send our results, and I think it's important. It can be also, if we have a good session, can be an opportunity also to start thinking something about a special issue for publications. I don't know, but okay, this is so please save the date and when will be the time, send an abstract.